Thanks, Sue-Ann. Good evening, everybody. I hope you're sitting comfortably. I'm going to talk about the project that Sue-Ann just mentioned. It's a project that's just finished. The final report will be on the AHDB website, hopefully within the next few weeks. This is the title, Investigation into Factors Affecting the Slippage of Clamp Silage, and that's the AHDB project number. And I'm going to start with an acknowledgement for the funding to AHDB, especially from Sue-Ann and also from Liz Jennifer when she was still at AHDB, for help and support during the project. And I'd also like to make a big thank you to the participating farmers for putting up with the visits that I made to the farms during the project. So the objectives were fairly straightforward. Firstly, to assess a number of farms that had slippage issues and to provide updated guidance on measures that could be introduced to reduce the risks of clamp slippage based on the findings from this project. Now here we have two pictures, two different farms, both with slippage. You can see on the left hand side that this region here is the new clamp face, but this would have been in there at that level, but it had all slipped forward. This farm, which possibly shows another issue more clearly, that actually the clamp was all at this height, but this whole region in front of that slipped forward. And like Sue-Ann said in the introduction, there is a big problem with the loss of nutritional value. And when you have a slippage problem, it is on most of the farms that experience it, it's a fight all the time to try and manage a good, clean clamp face. And both of these farms normally in a good year have a good normal clean clamp face, and you can imagine the frustrations when they have an issue with slippage. There has been advice, long-standing advice back to the 70s, possibly even earlier, on how to reduce clamp slippage. And I'm just going to run through what that advice was. First of all, one of the major aspects was do not overcompact low percentage dry matter grass, and generally here they're considering grass less than 25% dry matter. Some advisors suggest increasing the layer depth during filling from 15 to 25 centimeters for grass with less than 25% dry matter, which seems like a sensible approach to reduce that compaction in these wetter silages. There's also advice to increase the chop length at forage harvesting, depending on the percentage dry matter. So here are the guideline figures, and obviously chop length is something that's we talk about chop length on the forage harvester, but it really is a theoretical length of chop because you never chop each grass to the same degree. So 22% dry matter or lower, 8 to 10% centimeter chop length, 22 to 28% dry matter, 8 centimeter chop length, and then when you go to the higher dry matter, you go from 28 to 32% dry matter, 2.5 to 5 centimeter chop length, and above that 2.5 centimeters. Those are the advice that were previous, and then do not consolidate at an angle greater than 20 degrees during filling. Now, this is long-standing advice. When you actually look in the scientific literature, there is very little publications, if any, on where this advice has come from. So it was a great opportunity to actually try and understand what is happening now with clamp slippage. And I think it's fair to say that there's been more reports in the last 2 or 3 years of problems. Now, whether that's because farms are being more vocal about when they're having an issue, or whether it really is on the increase. And I think that's something that it's worth bearing in mind. So in total, visited 11 farms. The first farm that I visited was actually to establish the methodologies, and it's not actually included in the presentation. Grass silages both from the 2018 and the 2019 harvests were used, and data on silage harvest and management were collected during the visit on the farm. So a discussion with the farmer and how their silage making process was carried out. In terms of physical assessments, measured the clamp dimensions, both the width of clamp and the height of grass in the clamp. and then depending on the height of the silage, cored 4 to 6 samples in a vertical line from the central point in the clamp. And the reason I selected the central point is that's generally where that slippage begins, and that central point, so it's important to try and understand what's happening. So it was a vertical line, so starting within 20 centimeters of the top of the clamp, and depending on the slip zone, going as low as possible, as near to the floor as possible. Obviously, in this situation, it's not always easy to be absolutely methodical with that sampling process due to the slippage. And those cored samples were used to measure the silage density. So just quickly, and this has been covered a number of times in the Litch Farming Press and on a previous AHDB webinar, but by taking a core sample with a 2-inch, 2.5-inch diameter metal tube, you can measure the silage that you take out of the corer, you can weigh it, and that weight is then divided by the volume of the hole, which is the volume of a column, which is pi, multiplied by the radius of your corer squared, multiplied by the depth of the hole. And that gives you a very quick and simple way of measuring density. So that was measured at each of those points down the clamp face, and then the sample from that was used to do some wet chemistry analysis, highlighted there, so dry matter, NDF, crude protein, ash, the fermentation acids. It was also used as with a standard NIRS prediction, and some of that data will be presented later in this presentation. Also, I sampled 2 samples by hand taken from the clamp face, but not where that had been cut with a during feed out, so that I could get a representative sample for particle size assessment to see whether we had a particle size issue as well. So just moving on, covered a range of locations from Dumfries right down to Cornwall. They're not necessarily in the order I did them, but I did start in Dumfries and I did finish in Cornwall. And you can see they're mainly in the west of the country. I have an apology to make because there were a number of farms that did contact me over the last 2 years, and I did fail to go there, and they would have represented other counties not listed. This was the average clamp size from those 10 farms. So 3.4 meters high, 15.3 meters wide. Not excessively large. However, when you compare that to a previous AHDB study I did in 2017, they are larger than the average. Now, admittedly, there are 10 samples in here in the slippage project and only 20 samples in this study. But what it does show that we have a taller clamp and wider clamp. And if you think about the weight of silage bearing down on that area beneath, that volume of silage beneath it, maybe there is a weight issue exacerbating any slippage problem. And if we think about the width, a wider clamp per unit volume has less friction on the walls, so less silage hold, or less wall to silage friction holding it back in. So these 2 factors could be, and I say could be, contributory factors to clamp slippage. What I do want to show is actually the fresh matter density. Now, before we go to the fresh matter density, which is the second column in this, or the last column in this table, just want to look at the dry matter. And the previous data was suggesting that below 25% dry matter there was a problem. And we can see here there are 3 farms that are below 25% dry matter. This is the average dry matter from those 4 to 6 cores taken. But you can see some of the farms, as an average, had quite dry silage. However, many of the farms, if we look at, this is the minimum and the maximum dry matter in the brackets, we can see that many of the farms did have regions of that clamp that were low in dry matter, with the exception of those 3 there, which are hitting almost that 30% as their lowest. So maybe that wetter silage in that clamp is having an issue, but I don't want to dwell too much on the dry matter, because one of the issues when you have clamp slippage is that you're exposing more of your silage to rain. So this may not be representative of the crop that was harvested in terms of the dry matter content. I want to talk about the density because I think density is very important, and one of the previous factors was not to over compact your wet silage. Now, when we look at density, and I've done it on a fresh matter basis because I want to assess it on a weight in that silage clamp and what that might be doing. And the target I often give is 700 to 750 kilograms of fresh matter per meter cubed, which is not what it says there, so that's a mistake, but there we go. So we've got here in this column, we've got many of those hitting that 700 kilograms fresh matter per meter cubed target. However, we have a big range again shown by the maximum and minimum, going from 481 in that first farm 1 clamp to 896. So big variation in density, which happens on most farms, but it's important to understand where that variation in density is. So if we look at the next slide, I've picked out 2 specific farms from this survey, and they both had a mean density almost identical of 765 kilograms of fresh matter per meter cubed. On the farm on the left, this was one that was not so high, so I only had 4 samples, and we can see that the density is increasing as we go down those samples in the clamp. The farm on the right, completely different story, and we can pick out one point in particular that I've put in white there of 514 kilograms of fresh matter per meter cubed underneath some silage which is 965 kilograms of fresh matter per meter cubed. Now you can see that what might happen there is that actually starts to push down, forms a bulge, and that's where it starts to slip. And it seems quite logical to me that that is a scenario that's happening. So here on the left we have density increasing from bottom to top, from top to bottom that should say, and on the next slide, on the next farm, that was varying across the whole of that clamp. So when we take those individual clamps, and this is what this table shows, and what I've done here is I've taken each farm, I've looked at the density down the profile of silage of sampling in those cord samples, and I've subtracted a density near the bottom from the density further up in that profile. So when I get a negative number, that means that the silages are getting more dense as you go down towards the floor from top to bottom, increasing in density. And as you can see from this, there are only 2 farms where we had that increase in density as you go down, which you'd expect from settling and gravity. And all the other farms had regions lower in the clamp with lower density than regions above them. And some of these were very large. Farm 2, for instance, was quite small, but when we look at Farm 2 2018 was small. Farm 2 from 2019 had a very big difference with heavier or more dense silage above a weaker, lower density silage. And I think that is one of the big points from this study that we've observed, or that we found. So just looking now, and I've taken the 2 farms out that had increasing density as you went from top to bottom. And what I've tried to do in this slide is show how many meters cubed of silage it would take above a region within each of those individual farms, above an area where there was poorer density, to create an extra 1 ton weight. I hope that's clear, but please ask questions at the end if it's not. So what we have here on most of these farms is actually it only takes between 2 and 6 meters cubed of silage to create a 1 ton weight difference of silage beneath it. And that's putting pressure on that silage and increasing the risks of slippage. So farm 2 was pretty good here in terms of this variation in density. I've missed 2 farms out. So out of the 10 farms, 7 of them, I think the major issue was this inconsistent consolidation and lower density in lower parts of the clamp compared to above them. I just want to move now because one of the factors in the past was low dry matter, and that was the main issue perceived to be causing the issues with clamp slippage. If we look at this table, it's just the means, the maximums and the minimums of all the silages analysed. And we can see that the mean dry matter across those 10 farms was 29.5%. So not particularly low. However, you can see looking at the minimum across the other side there were some low silages, some low dry matters. Now within each farm, there was considerable variation in dry matter and in the other things I'm showing this evening. The other factor I want to pull attention to is NDF. Low NDF, 46, that's the mean, but we can see that there's a minimum there of 38. That shows that there's low fibre. Low fibre means that you've got high digestibility, good for feeding any type of ruminant, good production from it. But these are high quality silages that we're looking at. We can see the same again from the crude protein. So yes, the mean there, almost hitting the 16% target, which I like to see. We can see that we've got a maximum there quite high, minimum quite low, but these are within farm variation as well. So most of these silages were very high quality on the farms that I visited. There were regions in that clamp where the quality wasn't so good. When we look down at some of the other things we're looking at, ash content of 9.4, that's high for a grass silage, but again, we have higher ash contents in our earlier cut silages because the minerals have not been diluted by the rapid growth of fibre in the last week or two before harvest. Again, looking at the lactic acid to acetic acid ratio here, high lactic, low acetic, a good lactic to acetic ratio, so a good fermentation profile. However, when we look across here, we can see again there's big degrees of minimum and maximum, so variation within that clamp. In terms of total butyric, we can see it's not very low clostridial activity. Now, all of these above ethanol were all done by wet chemistry, so traditional chemical methods. Then these with the one beside them were actually using the NIR prediction. So we can question the accuracy of some of these that I'm going to pick on, and particularly the oil value. I think the NIR prediction for oil value is a little weak. So the absolute value here might not be 5.26 for oil, but it is indicating again that we're having high oil grasses, which goes alongside like the ash content that they're early cut because we have higher oil content in early cut silages. So what we're seeing within these studies is that this is high quality silage that is causing, or that is being seen on these farms to have a slippage issue. Now, I really don't want farmers to stop making high quality silage because high quality silage is the backbone of your winter production. But I think maybe it's increasing the challenge we have to keep that silage in the clamp. So just moving on, and some of the other things that I found in this study, which may be important on some farms. So what I've got here now on the left-hand side of this is a graph that shows the lactic to acetic acid ratio. So this shows you take the lactic acid concentration and the acetic concentration and you do a ratio from it. And we can see in this that on this farm, Farm 4 2019, there was a very good relationship between poor density and low lactic to acetic ratio, high density, high lactic to acetic ratio. Whereas on this farm, there is no relationship between density and that ratio. And on some farms, they were reporting back that when they cut the block of silage out, they got a gush of water and then it slipped. Now, that could be down to this lower density in certain regions again. And when you get low density, you trap more oxygen, you actually encourage a more acetic type of fermentation because you're encouraging things like enterobacteria to grow that cause acetic acid. Now, the reason why acetic acid could be important is that you also produce water and carbon dioxide when you have that. So you're increasing the dry matter losses, but that water could be retained in that clamp and actually increasing this slippage risk. Now, this was occurred on some farms and not all farms. There was good relationship sometimes, not on other times. So again, it could be a cause, but it's not the main cause or the main reason. Now, I want to just talk a little bit about the particle size. So for the particle size assessment, I used a modified Pennsylvania State particle separator. This had been adapted to add these two larger sieve sizes to the top of that sieve stack. It's part of a project that conducted by Lee and Sinclair at Harper Adams, and it was funded by the AHDB, not looking at slippage, but looking at fibre length and the importance of fibre length in terms of ruminant production. Now, what I found from this, so you have your stack, you put the forage in the top, you shake it in a specific manner, and then you pull off the particles from each of those sieves. This isn't the best of pictures, but it gives you an indication. This is obviously the bottom pan, next sieve up, and then we go in order. Now, what I found from this study was that we actually had, and this is percentage captured on each of those sieves. So the percentage fresh weight captured on each sieve, and we can see that in most of the farms, the majority of the fibre, the majority of the particles were collected on the 19mm sieve, implying that they were shorter than 32mm in length. Now, it's not an exact science because obviously particles can fall through vertically and be longer than the sieve width, but it does imply that maybe on these high quality and particularly on the lower dry matter silages that we were chopping shorter. Now, chop length is a very emotive issue, and I think it's something that we need to discuss fully in relation to cow nutrition, because there are very big benefits of that shorter chop in terms of intake, and it's a complex story. But what I would say is, if we've got these wetter silages, maybe that chop length does need to be lengthened to ensure that we can maintain that silage in the clamp, because the longer the particle size, the more friction it has and the more easily it will hold in the clamp. It's a little bit like building a block wall where you put all the bricks vertically on top of one another and you expect it to stand up. So I think there's something to play with this particle size. One of the issues I see in practice is that the modern forage harvesters are being increasingly designed for AD plants where they like a short chop, and there is a statement by many in the industry that they cannot physically chop this forage longer. Now, just moving on, almost at the last slide now, and we look at clamp filling angle. And the reason why clamp filling angle is important is because if we consider a 10-degree angle, then we're getting the weight. This is a hypothetical 10-ton tractor. This is the force downwards, 98 kilonewtons. But as we're going up that slope, we also get a drag force backwards of 17 kilonewtons. 20-degree angle, same weight down, same tractor, so same weight down, but actually we get an increased drag force backwards. And that's almost twice what it is at 10 degrees. And then at 30 degrees, it's almost another 17 kilonewtons higher than it is at 20 degrees. And what that means is that as that silage is being rolled, actually that tractor is struggling more up that bank, and actually it could be actually causing a rip zone in the silage as you're filling. So I would say that green, 10 is good, 20's amber, so borderline, but 30 is wrong. And one of the problems here is that with the modern tractors, we can actually incline and pack a steeper angle because those tractors are powered so much that they can do them. So I think clamp filling angle is still a very important thing, and we should try, if most of the time, to try and hit this target rather than either of these two, but we should never go above that 20-degree angle. I can accept that if you're filling your clamp over more than one day, there's an advantage to putting it in steeper, but many farms now are filling within one day, so they should keep nearer to this. That's just a graph showing the filling angle and how that drag force down the clamp, down the slope increases, and it's actually a very good relationship there. So just in finishing off, I think the real main risk factor is actually this inconsistent density during filling. So we need to consolidate the first load in the same way that we consolidate the 10th, the 20th, all the way through. Same procedure for consolidation. Don't wait, come in after 5 loads and start consolidating, and then don't get distracted and go off and do something else for a few loads and then come back and think you can get that even consolidation. You can't. I think clamp dimensions, the higher and the wider the clamp, increases the risk. But I think we can control most of that through this inconsistent density. And then over consolidation of grass silage with a lower percentage dry matter content, again, might be increasing that risk, but I don't think it's the major problem. It's this uneven consolidation that I think is having the bigger effect. But if you've got wetter silage, then consolidate it slightly less by doing that 15 to 25 centimetre changeover. On some farms, like I said, there is a relationship between this poorer density and poorer fermentation, which could again be adding to the problem. Like I said, with chop length, we do need to make those wetter silages that bit longer and try and control that better during filling. And then I think it's very important that we don't go above that 20-degree filling angle for the physics of the situation and the fact that actually, if you're filling steeper, you're using more fuel when you're consolidating the clamp. What I don't want you to change is high quality silage, because high quality silage is your best way of getting healthier stock, improving production from forage and reducing your costs. So I think we can control slippage even with these high quality silages, predominantly by looking at that first factor, but bearing in mind these other factors that I've also highlighted as potential risk factors. So yeah, follow the rules above and carry on making high quality silage. Now we have plenty of time for questions, and don't be shy, because this evening you're faceless, you're anonymous, so please ask away. Thank you.
Thanks very much, Dave. It was a very interesting presentation. And thank you everyone for bearing with us throughout the sound issues at the start. Hopefully you could hear Dave all right, and hopefully you can hear me now. So while I'm waiting for some questions to come up, I'd like to remind you that the presentation has been recorded, so you can watch it back on the YouTube channels. So Dave, we have a few questions in already. So the first question is, what causes a silage clamp to split rather than slip?
I think it's the same issue. I think it's the fact that we've got poor consolidation in one region. So you get that slip zone, that split, and you're lucky that it doesn't slip forward. It just sits there with that big slit in. And I think it is the same factors. It's poor consolidation, possibly more occurring in a wetter silage, but I'm open to be told I'm incorrect. And so again, that chop length might be having that effect, and that packing angle where I can see, and I've seen it on clamps where they're filling and rolling that clamp at a steep ramp, and you can see that the grass is pulling back, and it might just be causing that slip zone when you're filling, but then it really pulls apart during storage and feed out.
Thanks, Dave. And the next question is, are all the pits that have slipped filled by forage harvester gangs?
Ooh. Right. I think they were, but I can't guarantee it. Without looking back at the data, it's not something that's fresh in my mind, but I do think that they were all yeah, forage harvester gangs, but I'm not 100% sure on that. Obviously, on many of these farms, there will be some member of the farm staff actually rolling. Actually, I'm lying. There's at least one farm that was farmer filled. But that farm, he did tell me that he got distracted to go off and move cows at certain points as they were coming out of the dairy. So he would leave it for 10, 15 minutes and not roll it consistently.
Thanks, Dave. And how many of these 10 farms had a single cut in these clamps, or were they all a combination of a number of cuts which was causing the density variations?
The single versus 2 cuts is not the issue, which surprised me. I thought it would be, but some of these farms were definitely 1 cut in a clamp. Other farms did have 2 cuts. but quite often that slip zone wasn't on the interface between the two cuts. I assumed at the start of this process that I'd be seeing a majority that were two cuts in a clamp. What was consistent was the high quality, and I think I'd say that most of those farms were actually single cuts. I think if you're putting two cuts in a clamp, you do need to make sure that that interface between the first cut and the second cut, where you've got that potential for some top spoilage on that first cut, that you do remove any top spoilage to reduce the risks of that slipping, because that top spoilage will be high in oils because it's a waste, and oils are concentrated during the losses process. But I think the major issue is not one versus two cuts in a clamp.
Thanks, Dave. And just whilst we're on the subject of multiple cuts with variable dry matters being put into the same clamp, could that cause variability in density?
Interestingly, I found in both this study and the previous study that multiple cuts have a slightly higher risk of variation in dry matter, but the variation in dry matter, even within single cuts, is on many farms more than 10% dry matter units. And so many farms will have between 25 and 35% dry matter silage, even in a single cut. And the reasons for that are that most farms will mow their fields in a specific order, and they will pick them up in the same order with a forage harvester. But some fields will wilt much more rapidly than others. So you always get this variation in dry matter. I think the dry matter content could be having a cause, an effect, and causing more variation, and it will affect your ability to carry out consistent density because it's harder to compact drier silage. But also in terms of the animal feeding, this inconsistent dry matter across those within a clamp is causing problems in the cow. Now, what I have found in the past when I've looked at a multi-cut system, the multi-cut system, because you're cutting more of the grass when it's still lush and green, your variation in dry matter is actually less than if you're in a more traditional 2 or 3 cut system. Now, the exact influence that dry matter content has on slippage was very hard to detect in this study, because like I said, when you get a slip zone, often you've got 2 or 3 meters of silage in front of that of where your polythene is, because you can't actually now sheet it up, but it's getting wet. So the dry matter contents of those in certain regions of that clamp may have changed because of rainwater rather than forage dry matter at harvest.
Thanks, Dave. The next question is there a way to assess consolidation efficiency when the clamp is being filled?
I've been asked that question so many times, and I wish I could give you a simple answer. The simple answer is no. And the reason is that when so my Cora method doesn't work from the top of the clamp down during filling, because you've always got a bit of fluffy zone on the top of that grass, even if you are consolidating well, which really messes up the calculation. What I would say in terms of that consistency, most trailers that are delivering silage are a given volume, which you can measure. I said layer in 15 centimeter layer depths, or 25, depending on the dry matter. So you can do a calculation of how far you need to spread each load up your clamp to get that 15 or 25 centimeter layer depth by doing the calculation of the volume of the trailer and then the volume of a 15 centimeter deep strip of grass being pushed up into your clamp. And you can also take into consideration the width of your buck rake on that. And again, I think that calculation was in a previous AHDB webinar I did, but it is a simple calculation, and that way you can make sure that you're doing the same thing, load in, load out, and you're consolidating the same. So you don't need an absolute value during that filling, but you do need something that you can gauge very quickly and easily that you're doing the same thing for each load.
Thanks, Dave. And the next question is, besides the inconsistency of density, looking at the ranges of silage in the silage analysis table, it appears that we should also look at producing a more consistent crop at harvest time. Is that right?
It is. One of the issues, and why I didn't dwell on that consistency too much in that, is when you get slippage, different parts of that slip zone will be changing differently depending on how much air is there. So when we get air coming into the clamp, we actually lose the most nutritive part and we retain the least nutritive part. So some of that fibre differences could be the fact that we've lost all the lactic acid, the sugars, and we've concentrated the fibre. So whilst I agree with the comment, we do need to be more consistent, and that's what a multi-cut can do, because we've got more green grass, less stem. Some of those differences will have been down to spoilage because of the slippage rather than the quality of the grass going in.
Thank you, Dave. And the next question is, how should I make my grass silage as I do not have a clamp and just a pad?
Okay, so I didn't visit any pads in this study. And when you have a pad, you actually have some different challenges and some potential benefits and some potential negatives. So when you do your pad, you need to assess how wide you're going to go. You still need to fill in those even layers, but you need to consolidate both left to right and back to front. And if that pad is on a concrete pad, I think the chances of slippage from that are lower than a standard clamp, because you actually have that friction along the floor with the edges of that clamp where you've got less silage actually helping to hold that back. So I would say you're far less risk of slippage. Just make sure you sheet it properly. That's a different issue.
Thank you, Dave. And the next question is, did you consider the grass species in your study? So tetraploids versus diploids, cell wall size, for example?
Short answer, no. Most of these were perennial ryegrass lays that were a fairly standard mix of those type of mid to longer term lays. So I didn't consider grass species. I would say I think it would have little effect in terms of the ryegrasses, and they were all ryegrass dominated. Whether if we start introducing things like timothy or fescues in there, they could have a positive because they are generally that bit stemmier. But what does that do in terms of cow performance and grass production from your given acreage of field would be a different question. They were, just a point, they were, I would say, dominated by ryegrass. I think there were very few there that had high percentages of clover in them. Okay.
Thanks, Dave. Next question is, do you think that stepping the face could have a positive effect if you have a clamp that is slipping?
There are a couple of things on if you've got a slippage problem that could help. One is stepping. My problem with stepping is that you're increasing your surface area of feed out. So one day I did think maybe if you could step the middle 2 or 3 blocks in the center of the clamp rather than the whole face, that would reduce the amount of surface area for feeding. And then another piece of advice that I picked up from Hevin Richards was actually cutting in a concave manner so that the middle of the clamp is further back than the side walls. Again, that increases your surface area, but you're actually allowing more frictional resistance by having a greater bulk of silage along the side walls.
Thank you. And the next question is, if you put straw or dry maize in the bottom of the clamp, would that help to stop slippage?
I don't see why it would. I can't think of a logical reason why it would. And most farms are harvesting their grass before their maize, so it's going to be a challenge to get those two to coincide. That would be my comment. I just don't see why it would, because it depends on how thick that layer is, but a lot of these clamps aren't actually slipping from the bottom, they're slipping halfway up. So I don't think it's a bottom issue as such.
Okay, thank you. We've got a comment here that they appreciate there are other contributing factors as you've covered, but do you expect to see more slippages in clamps with clamps getting wider?
Pass. I mean, some of the clamps I went to were very wide clamps. I think there is an increased risk, but I'm hoping that we can actually try and hit a 30 to 32% dry matter target more frequently in the future, which I think would resolve a lot of the problems. I also think if we follow those rules in terms of density, even density going up the clamp, and also the filling angle, I think we could move away from it even in the wider clamps. And what I would say, when I travel in countries that have much wider clamps than the UK, slippage generally isn't an issue. And I think it is something about the way we're filling our clamps in terms of that filling angle, and possibly the tendency to have on most of those farms some silage in there that was 25% dry matter or lower, some silage, not all. And I think that's possibly where the bigger issue is.
Thank you. The next comment, you've mentioned that the oil level is being higher in young grass and oil is a lubricant, so does this have a bearing for slippage?
It's something I'd like to investigate further. I think it possibly does. And I think on the oil question, then I don't, like I said earlier, I don't want us to move away from these high quality silages, which will have a higher oil content. But one thing that does happen with oil, it's like ash, it's a gauge of dry matter losses. So if we are having an extended wilting period, we're losing the sugar, we're increasing the oil content. If we're not controlling the fermentation process, so we're increasing the dry matter losses, we will be, during the fermentation process, we will also be increasing the oil content. So it's something that I think needs further investigation. I think it's an interesting question that does warrant a bit more further investigation, and I'm a little bit frustrated with myself that I didn't actually measure the oil rather than using an NIR prediction for the oil content, because I think it would have been more accurate to have done it through wet chemistry, but it's quite an expensive analyte to analyze.
Thanks, Dave. And is there any silage additive benefit in helping to reduce slippage?
Coming back to what I just said about those dry matter losses, I think if you've got a silage additive, so it's very difficult to just take that word silage additive because they're not all the same. So if we've got a silage additive that's improving aerobic stability through a fermentation process where it's producing more acetic acid, which is many on the market, could, and I say could, be increasing the risk of slippage. What I would say is, and I think that's something again that we don't have enough information on, what I would say is if you're a farm that always has or frequently has a slippage problem, a chemical additive will reduce the problems caused from reduction in nutritive value after it's slipped, because the chemical products actually control the microbial population for a longer period of time when air is present. So I think if you're a farm that has that slippage problem year in, year out, and you can't solve it through the things I've said this evening, then maybe you need to consider a chemical additive so that you actually lose less quality when you have that slippage problem, because they're inhibiting many of the microbial populations. The problems with the biologicals that inhibit those microbial populations, they're only as good as the anaerobic conditions are in your silage clamp. And after a week, 10 days of you having oxygen present, those chemicals that those biological the microbes are produced in that inoculant are being degraded, and so they stop having that antimicrobial activity.
Thank you,
Okay.
Dave. Thank you. And are there countries that have a better handle on slippage and general silage quality at the moment that we ought to be looking to?
Like I said earlier, there's a lot of countries that don't have a slippage issue, but they can make drier silage very quickly because they have better weather. In terms of quality, it's Britain many farms make very good quality silage under British weather conditions. And there's as much variation in silage making ability in Russia as there is in Britain or many countries. I would say the ones that seem to do it more consistently better than most places are the Czech Republic. I can't tell you why, but they're making a lot of lucerne and maize silage, not grass silage. And I think wetter grass silages in the western part of Europe are more challenging.
Thank you. And were the drier silages that split higher than the others?
Ooh, specifics like that I can't tell you off the top of my head. I'm trying to think where they were. I don't think they were, no, but that is it's not a definitive answer. I don't think they were any higher.
Okay, thank you. And were any of the farms using a forage wagon to try to get a longer chop length?
One farm used a forage wagon and a precision chop together. So they were doing some with forage, they were both in the fields at the same time. And I think that was exacerbating their problem. The other farms were not using a forage wagon, they were all using precision chop. One of the issues you have with forage wagon silage is that it's more difficult to consolidate consistently because one, you've got longer chops, so it's harder to compact, and also the way it comes out of the forage wagon, it often comes out in a ball or a roll, so it's more difficult to spread. So I don't think the forage wagon angle is necessarily a solution. And if you're going down the forage wagon route, you need to make sure that you're more precise and you follow the forage wagon rules on how to make high quality silage, which you can do. There's some good contractors out there with forage wagons that know exactly what they're doing, but there are some that are doing a poorer job.
Thanks, Dave. And another question here. Do you think there were more issues last year due to the cooler, wetter harvest conditions?
From what I heard, no. I had as many queries the year before as last year, so I don't think so. But you know, I only hear about a very small proportion of what's going on, and it's something I think in many things I think the farming industry need to be more open with issues, and maybe that's something that going forward we could have particular discussion groups for, or people putting in facts so that we can actually get a feel for what the real problems out there are with many aspects of modern agriculture and where the problems are, so that we could actually direct resource to examine what is going on. But from my limited hearing, I don't think it was. I think there was as many problems the year before as last year.
Okay, thank you. And another question here, if you had the choice, would you wilt the silage for longer to increase the dry matter, or chop longer with potential negative effect on compaction feeding?
I would never wilt for longer. I would always try and get that forage harvest to chop it a bit longer. I think we need to have a target of 30% dry matter, but if we don't hit that target within 24 hours, we need to be picking it up because our losses in the field increase. So if I just give you an example, a 28-hour wilt, 6% losses in the field, that's 6% of the sugar, that's 6% D value. So I would never go down the longer wilting option.
Okay, thank you. And what would your estimate be of the losses from a slipped clamp?
I did do some calculations on temperature, which I didn't include in the presentation. I was just measuring temperature at different depths in the silage clamp to have a feel for losses. And on some of those farms where they had higher temperatures, I could calculate that they lost 50% of the ME from that particular region. Now, the temperature varies within the clamp at different heights quite considerably, depending on how much oxygen is getting in. So it would be very difficult to come out with an actual loss figure for each and every farm there without doing a lot of detailed work. But I would say most of those farms would be losing at least 20% because of that slip. And some of those farms are probably losing 40, 50%.
Okay, thank you. Hello everybody, thank you for your patience. I'm afraid Dave's internet has cut out and his network has crashed. So what we'll do is I'll take down a note of all your questions and we'll get them out into an email. The answers to those, we'll get them out into an email after this webinar in the next couple of days. So we will get your questions asked, but unfortunately Dave's internet seems to be messing around, so I'm really sorry about that. We will make sure we answer all of your questions. So thank you very much all for listening. I'm sorry we've had to cut it short. We will get back to you by email. And please keep an eye out on the AHDB events page for future webinars, and hopefully there'll be less technical difficulties. And Dave can't hear me, but a thanks for Dave for taking the time out of his day to talk to us. So the recording will be emailed in the next couple of days. It'll also be available on the YouTube channel, and we will get back to you with answers to your questions. So thank you very much for listening. I'm sorry we've had to cut it short, and I hope you enjoy the rest of your evening.